So the first rule with significant figures is that all non-zero numbers are significant. This one's kind of logical. If you have 732 as an example, all three digits are going to be considered significant because they're not zero. Significant figures, what makes it a little bit tricky are the zeros. Sometimes zeros are significant and other times they're not. So with this rule number 1, anytime you have a number that's not zero, it's going to be significant, always. Rule number 2, any zeros between non-zero numbers are also significant. So in this number, we have 301. The 0 is significant. I like to think of it as a sandwich. This is a zero sandwich. You have a number on either side with the 0 in the middle. Therefore, the 0 is significant. There's no doubt in my mind that that's a significant measurement. So both of these values right now have 3 significant figures. Okay, so once you start adding decimal points, it makes it a little bit trickier. If there is a decimal point, any zeros to the right of the last non-zero are significant. Let me say that again. If there is a decimal point, any zeros to the right of the last non-zero are significant. Okay, so taking a look at the first number here, we have 320 kilograms. Notice there's a decimal point. Since there's a decimal point, we're going to start on the left, and I like to draw an arrow. Start on the left and work my way right. So I find my first number that's not a 0, which in this case is a 3, and all the values are considered significant after the 3. So this value, 320 kilograms, has 3 significant figures. In the next one, I have 320, but there's a difference. There is no decimal. Since there is no decimal, I'm going to start on the right and work my way to the left. I'm going to do the exact same thing. I'm finding my first non-zero, which is a 2, and the 3 is also going to be considered significant. So in this value, there's only 2 significant figures. So a decimal point can make a difference between 2 sig figs and 3 sig figs, or 3 sig figs and 5 sig figs, depending upon the number. So you want to be very careful with your decimal points, making them an intentional decimal point. So it's a clear decimal point, so it really looks like a decimal. Okay. Next one, we have 0.70 meters. Notice I have this 0 here for communication. There's a decimal point. I'm going to start on the left and work my way to the right. So I have the 0.7. That 7 is significant, and the 0 is significant. So this has 2 significant figures. So I have to have a non-zero number to start counting sig figs. I can't just count all the numbers and that's my answer. And the last one has a decimal. I'm going to still start on the left and work my way to the right. So I have the 7 and the 0 as significant figures. So this value also has 2 significant figures. So this one has 2 zeros that are not significant. This second 0 here, which I'm going to highlight, this is a placeholder 0. Sometimes you need a placeholder 0 in order to keep the same value. When we're dealing with sig figs, we don't want to change the value significantly. We're going to talk about rounding in just a moment, and we're going to round our answers, but we don't want to significantly change the value. So if we, instead of writing 0.070, wrote 0.70, we're changing the value significantly. Any change that we make should not significantly affect the value. So rule 1, 2, and 3 are the big rules that we're going to be focusing on right now. Rule 4 is that any number that is used to count things or is a direct conversion has an infinite number of significant figures. So for example, there are, if I had 45 desks in a room, I'm going to have 45 desks. If I had 20 students in a room, I can't have half a student. If you can't have a fraction of it, it's going to have an infinite number of significant figures. So there are exactly 10 pennies in 1 dime. So the helpful hints here are kind of a nice, easy way to help you remember this. So if the value has a written Oh. If the value is written, I think makes a little more sense. So if the value is written with a visible decimal point, then you're going to go to the left end of the value, moving right to find the first non-zero value. You're going to then count it and every number to the right. So a nice little way to remember this is that if the decimal point is present, you start on the left or the Pacific side of the equation. So if you think of the United States map, if you take a look at the United States, the map, the Pacific Ocean is usually on the left-hand side and the Atlantic is usually on the right-hand side, so you can use this to help you remember which side you're supposed to start. So if the decimal point is present, which is starts with the letter P, and Pacific starts with the letter P, both of those help to remember which side you start on. Then the opposite, if the value is not written with the visible decimal point, you're going to go to the right end of the value, moving to the left to find the first non-zero number, count it, and every number to the left. So if the decimal point is absent, you start on the right or Atlantic side of the equation or the number. So in these examples here, in this first example, I have the arrow already here, but you're going to start, because there's a decimal point present, you're starting on the left and working your way to the right. So you'll have the first non-zero value is the 1, so you'll end up with 5 significant figures. Both the 0 that's sandwiched between the 2 and the 4 and the last 0 are considered to be significant. In the next one, if the decimal point is absent, you start on the right. So I start over here and work my way to the left. My first non-zero also is a 1, and then all the values before it. So I have 4 significant figures in this number. Rounding off numbers, we're following traditional math rules here for rounding. If the number, we only look at the number directly beside it. So if the number directly beside it is less than 5, we're going to round down. If it's 5 or above, we'll round up. We don't do like chain reaction rounding. We only look at the very next number. In a series of calculations, it's best to wait to round to significant figures till the last step, because every time you round, if you're performing a mathematical operation that you're doing 10 different calculations, every time you round, you're increasing the amount of error you have, and you're trying to reduce it. That's the goal of significant figures. You'll want to wait to the end to round. So we're going to do some examples. Let's say I had 732,000 something grams, for lack of a better term. So there is no decimal point present, so I start on the right and work my way to the left. So I have 1, 2, 3 significant digits. Sometimes you'll be asked to round to a certain number of significant digits. In this case, let's say I wanted to round to 2 significant digits. So I want to have 2 significant digits, or 2 significant figures in my answer. In order to do that, I'm going to take the 2 largest digits. So my first digit, that's the largest, is the 7. My second digit is the 3. Okay, so I have my first 2 digits. Now, this is a question I always ask with this. Is 73 approximately the same value as 732,000? The answer is no. This is a situation where you need some placeholder zeros to keep the approximate value. You can kind of think of this as your bank account. If you had $732,000 in your bank account and you went to the teller and they gave you $73, you're probably going to be unhappy. You want to keep the value approximately the same. The whole goal here is to keep the approximate value as well as communicate the appropriate level of accuracy and precision. Here's another example. So this value has a lot of numbers in it. There's no zeros whatsoever, so it's very easy to count my number of significant figures. So I have no decimal, so I'm going to start on the right, work my way to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9 significant digits here. Let's say the question was asking you to round to 3 significant digits, or 3 significant figures. We're going to, again, take the biggest 3. So we're going to take the 7 again, the 3, and the 5. Okay, so we have, for 3 significant digits, we have 7, 3, 5. But again, 735 and 735 million are not the same value. So what we're going to do, okay, you need some placeholder zeros here to help make sure that we keep the same approximate value. The other thing that you want to keep in mind is notice how I have no decimal. If I were to add a decimal, that's going to make all those zeros significant, which I do not want to have happen. I only want to keep the 7, the 3, and the 5 to be significant.